Most of what we've done is just like some theory, like what happens, trig identities, stuff that's like, whatever. Today what we're going to do is actually use it for something. So we're going to solve a few word problems and that sort of thing. So we're going to do specifically right triangles. And with right triangles, the thing is going to be, we don't always have a right triangle, but when we do, all this stuff's going to work out. So this is solving right triangles. Now I want to focus a little bit on word problems for this, but first let's get used to, well, how do we set these up? So whenever we're solving a right triangle, or any triangle, that means find the measure of all sides and angles. Now, since we do have right triangles, specifically Pythagoras' theorem is in the mix here. But let's go ahead, and I'm going to reuse the same triangle over and over again. So, get this set up. Okay, so here's my triangle, and I'm going to indicate that this is indeed a right triangle. All right, so let's say I have x down here, y right here, and let's say this is 12 and this is 9. Okay, and I want to find x, y, and z is going to be this extra side right here. That all came out sloppy. Let's find z first, okay? So z is going to be this side right here. Oh, I can't find z first. Actually, I can find z because this is a right triangle, which means Pythagorean theorem works. So I would have z squared plus 9 squared equals 12 squared. So 81, 144, z squared. Subtract the 81, so 144 minus 81 is 63. And then I square root that. Now, we did simplifying radicals, right? So I would expect you to prime factorize that. That's what I get when I prime factorize it. And I get 3 root 7. Exactly. So that's part of my answer. I found z, but now I need to also find x and y. X and y are angles. So look up so that you're catching what I'm doing. So I'm looking at angle x here, and I'm going to have to use the sides. Since this is a right triangle, I'm going to use trigonometry. This side is adjacent to angle x, and this side is hypotenuse to angle x. Any questions on how I identified those sides as adjacent and hypotenuse? Okay, so that means that I can actually use cosine here. So cosine of x is adjacent over hypotenuse, so 9 over 12. I could reduce that, but there's no need. I'm looking for an angle. Whenever I'm looking for an angle, I use an inverse. So we'll inverse cosine 9 divided by 12 and get x is about 72 degrees.
That's not what I had.
Oh, I forgot my calculator's in radio mode. Hold on. I have to switch it because the other class. So let me try that again. 9 divided by 12. 41 degrees. Is that better? Mm-hmm. 41 degrees. There we go. Okay, so there's my 41 degrees. So if x is now, how many degrees are in a triangle?
180.
180. So I could do 180 minus 90 minus 41, and that will give me y. Mm-hmm. Does that make sense? And I get 49 degrees. And now I've solved the triangle. I know everything about it. Y equals 49 degrees. Now I could find y, just FYI, opposite over hypotenuse. I could use inverse sine. Let's set up another. So let's say this is x, this is 7. Let's say this is 8, y, and z. Okay? So I could then say, let's find x first. So as I look at x, oh, I didn't mean to set that up that way. I'm sorry. We'll do it again. I didn't want to do it that way. Oh well. We'll have to do a few more. All right. So we can find x by Pythagoras theorem. So x squared plus 7 squared equals 8 squared. So I have 49 equals 64. Subtract the 49. And I get 15, so x squared equals 15, so x is root 15. Now, if I can, I'm going to avoid using things that I've calculated. So I'm going to try to avoid using that root 15. To find z, I have opposite and hypotenuse, so what do I write?
Sine.
Yep, so sine of z equals 7 over 8, and I'll inverse sine that. Whenever I'm looking for an angle, I am going to use inverses. Now, if your calculator throws an error, that means you used the wrong one, or you put it in the wrong order somehow. I get 61 degrees there, which means 29 degrees for y by subtraction. 180 minus 90 minus 61. And now I've solved my triangle. I know everything about it. Any questions how I'm getting any of that? No? Oh, my computer's actually being kind to me today. So far.
What is that black bar at the top?
It's probably a cord that's dangling in front of the
Oh, it's a piece of paper.
or a piece of paper or something. Okay. All right, so now let's say maybe I give you an angle. Okay. So now I'm looking for x and y. And z is inside here, but we can get that z pretty easily. So I'll just skip that. That would be 180 minus 32 minus 90, right? And that would give me z. So I'm just going to use this 32. Let's find x. So I have adjacent and hypotenuse. So what will I use?
Cosine?
Cosine. But cosine of what?
32.
32 equals
24 over x.
Yep. And whenever we have fractions, what do?
Clear the fraction.
Clear the fraction. So I'm going to clear it by multiplying by x. Now I like to. Now you can calculate that cosine 32 if you would like, but I like to do it at the end. So this is all one group right here. Okay, that's all one thing. So I'll divide by cosine 32 on both sides. Order is going to be important. That's in the denominator. So x equals, now we can actually do that. And I get about 28.3. We'll want to know our directions where it's telling us to round. So that gives me x. What about y? So if I look at y, use a different color here. Y is going to be what?
Tangent.
Well, it's opposite of the 32, right? And I'm not going to use this x because I calculated it. If I use it, I'll be getting a rounding error. So in trigonometry, that'll make a big difference. One of the big applications of trigonometry is positioning, astronomy, and rounding errors would compound really big, especially if you're talking about like sending a satellite to Mars. If you have a big rounding error, Even if you have a little one, that little rounding error is going to translate into miles and miles and miles, and you will miss your target, which would be very sad. Millions of dollars down the drain. So opposite over adjacent, so that's tangent of 32 equals y over 24. Any questions where I got that? Multiply both sides by what?
24.
24. So 24 tan 32 equals y. And I get about 15. After rounding, the 9, I get 14.9968. So if I round up the 9, it changes to a 10, and then it rounds up. Oops. Shall we do one more that's like that? Or are you good? If you're good, I'll move on to the next thing that we need to know. Does anyone need to see another example?
Okay, so wait, why did you find the 32 angle and then why did you find y? I mean, you switched.
Well, I was given the 32. I was finding y using the 32.
No, I mean, like, why did you find 32 and then not z?
Oh, z, well, when I started talking, I said we can find z pretty easily by 180 minus 90 minus 32. So I just kind of skipped that one. All right, let's do one more. Let's say I have 50 degrees right here. Let's say I have x right here, 28 right here, y, and z. All right, so z is going to be 40. Why is z 40? Because of subtraction, right? So we got that one. Get the easy one out of the way. So now we have x and y. How can I get y? What trig function would I use?
Hypotenuse over adjacent, or adjacent over hypotenuse.
Adjacent over hypotenuse, which is what?
Cosine.
Cosine. So cosine of 50, so something always has to go here. And this doesn't mean cosine times 50. This is all one thing, cosine of 50 equals y over 28. I'll multiply both sides by 28 to clear out that fraction. And y equals 18 after rounding. Okay, to get x, so I'm going to avoid using that y.
That's hard. It's like immediately I see that I'm like, let's find that.
Okay, so I'm using this angle.
Yeah.
So I have opposite and,
Hypotenuse.
okay, so what do I use?
Sine.
Sine of 50 equals x over 28. Multiply both sides by 28. And hopefully at this point is pretty familiar to you. I get 21.45. Again, we'll note, we round at the end, whatever the directions tell us. All right, we're going to do one word problem, at least for our notes. We'll do more for practice later. So example word problem. The angle of elevation from a point on the ground to a nearby plane is 72 degrees. If point is looking up with its eye. So we have an angle right here of 72 degrees. And we know that the plane is 5,280 feet in the air. Now the next question becomes, now it's asking how far is the plane from the point? Well, do I mean this, like over the ground? Do I mean that? Or do I mean like this direct distance? I'm going to say I mean the direct distance. I want that. I want the direct distance. I don't want this distance over the ground. So if I wanted that distance over the ground, I might add the phrase, how far is the plane from the point over the ground? So the ground coverage. All right, so I have opposite and hypotenuse, so that's sine. So sine of 72 equals 5,280 over x. Multiply both sides by x to clear it. And now what do we do?
You divide by sine 72.
Yes, and notice I'm putting the x in front. I don't put it next to the 72 because then it looks like I mean sine of 72x. And I don't mean that. I mean x times sine 72. So x is going to equal 5,280 divided by the sine of 72. And I get, it is 5,540 or 51, 5,551 feet. 52 feet after rounding. Direct distance. Okay. We are now going to find, so the next few questions are tricky. So find sine of the angle, cosine of the angle, tangent of the angle, cosecant of the angle, secant of the angle, and cotangent of the angle for the terminal ray through the given point. For any question like this, generally draw it, okay? And it is going to be a right triangle. So, let's say I give you the point -3, 7. So I will draw a rough sketch. It doesn't have to be on graph paper or anything like that, but I'm going to estimate where -3, 7 is. And that it's like over here, right? And I'll draw a thing through it. You see what I'm doing? So this is the point -3, 7. And what I'll do is, now I'm not interested in what the angle is. If I wanted the angle, I don't have to do 6 of these. I just need one of them to find the angle. So I'm not interested in that. I'm looking for the ratios. So I'm going to complete my right triangle here. And my angle is right here. Okay, so that's my angle. Well, what's this length that I just marked out? What would that be? -3. And what's this length right here?
7.
7. Okay? Now I'm going to use Pythagorean's theorem and find this missing part. Pythagoras. So that I have the whole triangle. Don't just put an X there and say it's good enough. No, it's not. Figure out what it is. I get root 58 after Pythagorean. So root 58. So I want to know which quadrant I'm in. I'm in quadrant number 2. So sine is positive, cosine is negative, tangent is negative, which means cosecant is positive, secant is negative, and cotangent is also negative because these are reciprocals. All right, so sine of my angle is opposite over adjacent, so 7 over root 58. And I think your book rationalizes, so we'll go ahead and rationalize. That was from the previous chapter. cosine of my angle is adjacent over hypotenuse. So that's 3 over root 58, which becomes 3 root 58. That's a 5. Blah. Right there. 3 root 58 over 58. Now notice I actually do write this first thing because I will need it. Tangent of my angle is going to be negative 7/3, opposite over adjacent. I did move my negative up. Now, to get these, I just flip the others. So I'll do that in a different color. I'll do that in black right here. So cosecant is sine flipped. So I flip that around. I'm going to flip this one around, not that one. That would be a lot of work. So I'll get root 58. Oops. Okay. Root 58 over 7. No rationalizing necessary. I'll flip this one around for secant. The root 58 over 3. And I'll flip this one around for cotangent. So cotangent is going to be negative 3 over 7. Okay. Try another. Same question. So we're going to find sine, cosine, tangent. Were you not done?
No, hold on.
Okay.
I'm good now.
Good now? Good. All right. So let's say I have the terminal ray at negative 5, negative 9. So I'll draw a rough sketch of it. Negative 5, negative 9 is like down here, right? And so my terminal ray would come around and go through there. So here's my terminal ray. And then I complete this triangle, right? Here's my triangle. And here's my angle in here. There's my angle. That's my reference angle, right? So this is negative 9 and this is negative 5. Now I am going to keep those signs there. So we do this right. We'll Pythag to get this side. So we Pythag that. And we get root 81 plus 25, so root 106. All right, so what would be...
Keep the negatives and stuff with this? Or with the Pythag or no?
No, not when you Pythag it, no. But when we start writing these. So what would be the sine of the angle?
Sine negative 9 over root 106.
And then we'll rationalize it. So negative 9 root 106 over 106. Okay, cosine. What would be the cosine of that angle?
There goes 5 over root 106.
And we'll always move our negatives up to the numerator if necessary. Rationalize. All right, how about tangent? I don't
Yeah.
They wouldn't be negative, but it'd be reduced. Okay, so now I'll go ahead and flip these to get the others. So cosecant is going to be root 106 over 9. I'll keep the negative at top. Any questions how I got that one? I just took that and flipped it. I didn't flip this one because then I'd have more rationalizing and canceling and horrible stuff. So I just go back to that. It's easier. Secant. Flip that one. Keep my negative at top. And cotangent. Flip the tangent, right? So when you're doing your homework, something that would be pretty convenient is actually if you put the answer right by the number. So I'm going to show you what I mean by that. So you might have a question like as follows. Example. In triangle ABC, A equals 4, and angle A equals, let's say, 35 degrees. And angle C is right. Find the other sides and angles. So when you have a situation like this, I would expect you to draw the triangle. So we would draw it. Now I have triangle ABC, so I'll write A, B. Now it tells me that C is the right angle. So C must go right here where I drew my right angle. The other 2 points, it doesn't matter where I put them. Now look what it says here. Little a is 4. So notice how I used the capital letter to mean the vertex. So caps equal angles and vertices. The lowercase, see this would be little a. You see how it's across? And little b would be across from the capital B. And little c would be across from this capital C. You see what I mean? So we're saying that this is 4. And this angle right here is 35 degrees. Now what would be helpful in your homework, like let's say this was number 101, okay? It will be convenient for your homework if you put A, B, C, angle A, angle B, angle C, so that when we go over it, you can find, and then just put a big box around this. Then we can check your homework way faster. Because there is a lot of work with this, right? It's not necessarily difficult, it's just a lot of work. Well, we know A is 4. We know angle A is 35. So just plug in that information that I have, and then I'll find the rest, right? And we've already done an example of this, so B is down here, right? So if I was looking for B, I have opposite and adjacent. So I'd say tangent of 35 equals 4 over B. Clear my fraction. So this is similar to what we already did. And B equals 4 divided by tan 35. So when you show your work this way, it'll be easy to, and I get 5.71. So if I see that, say you wrote 6 right here for B, I'd be like, well, they got that part wrong. I'll now look into the work and see what happened. C was given, or angle C was given to me as 90. So I can find this one pretty easily. What, 55? Is that right? 55 degrees. C is not 9. How do I get C? Well, I have opposite and hypotenuse, right? So what do I use for that? If I want to find C.
Pi tag?
I can't, I'm not going to use this 5.71. I'm not going to pi tag it. So I have this angle.
Sine.
I have this side, and I'm looking for this side. So sine, opposite over hypotenuse. So sine of 35 equals 4 over C. Clear my fraction. And divide by sine 35. .97. You see what I mean by putting a big box for these, where that is? Alright, I think we are going to go ahead and stop right there. We will finish this section tomorrow.